Okay, students, we are moving to another topics. I think you are enjoying thermodynamics and you are seriously preparing thermodynamics topics. As I said to you, at least 2 questions you can expect from thermodynamics. Okay, this is another discussion based on previous questions. That is bond enthalpy. What is bond enthalpy? During a chemical reaction, during any reaction, there will be bond breakage in reacting site and bond formation in product site, in protected site. Okay, literally bond breakage is endothermic. This is exothermic. In the definition, we will take bond enthalpy is considered as bond breakage. It is the heat required, this is the heat required per mole to break a particular bond. And the bond enthalpy is always an average value. It's an average value. You will understand that in detail. It is an average value. Okay. Now, what is the meaning of average value? Suppose you have a CH4 molecule. It has 4 CH bond, fine. Suppose you have 1 mole, total 4 mole CH bonds. 4 mole CH bond. The energy required to break this, suppose E1, this is E2. Although both are same, these bonds and these bonds are same, but the value will be different. Because this breakage happens after this breakage. I will tell you one beautiful example. Suppose you have 2 apples, you are a kid. You have 2 seeds in your hands. Your elder brother came and snatched away first seed. You protect. Okay, somehow he snatched away. Very notorious your elder brother. After eating that, he came again. He came again to snatch the second one. Even though same apple, same person, but your protection will be different. Obviously, it will be more stronger. That principle happens here also. You have E1, E2, you have E3, you have E4. Okay, which will be take as delta H0 bond enthalpy of CH, which will be taken. This is average. You take the E1 plus E2 plus E3 plus E4 divided by 4. Okay? Therefore, bond, that's why we say that bond enthalpy is an average. Now, bond enthalpy helps to calculate relation between delta H0 bond enthalpy and delta H0 reaction or delta H0 formation or delta H0 compression, anything else. Generally you can say reaction. Here delta H0 reaction is equal to summation of bond enthalpies of reactants. Okay, because in this case, in the case of bond enthalpies, here the breakage happens. That's positive. That value will be always positive. Fine. This is input for the reaction, and heat input minus summation of bond enthalpies of products. In the case of products where bond formation happens, that will be always negative. That is output. Okay. Therefore, delta H0 reaction is equal to input heat minus output heat. Input means the heat given. In terms of bond enthalpies, heat is given to break the bond. Heat is released when output is you will get the output when heat is released, when bond is formed. Therefore, this tells you will be negative when it is greater. You will be positive when this greater. That is, total bond energies of reactants are greater than total bond energies of products. Then it will be positive, endothermic reaction, because where input heat is higher than output heat. Fine. In reverse, output heat is higher. That is, heat released during the heat released when product is formed. Bonds in product sites are formed. That reaction is called an exothermic. Therefore, remember, when you connect bond enthalpies with enthalpy of reaction or enthalpy of formation or enthalpy of combustion, first summation of bond energies of reactants taken, then subtract from that summation of bond energies of products. There are a lot of questions in various examinations. Let us take some example from IIT, JAM IIT questions. Okay, I will write the first question. The enthalpy of formation, for CH4 gas, C graphite, H gas are minus 75. This is C gas, I am sorry, not graphite. Minus 75, 717 and 218 kilojoule per mole respectively. What is delta H0 bond enthalpy of CH? That's the question. You are given enthalpy of formation of CH4, C gas and H gas. Enthalpy of formation of CH4. CH4 is formed from its constituent elements, that is C plus 2H2. When you write the formation, this is graphite, this is gas. Okay. Now, you wanted to calculate what is CH bond enthalpy. You have the enthalpy of formation of this one, you have the enthalpy of formation of this one, you have the enthalpy of formation of this one. Okay? Now we know that suppose you take it, this is an enthalpy of a reaction. The enthalpy of reaction, if you know the enthalpy of reaction, here what is the enthalpy of reaction? You take the enthalpy of reaction, that is enthalpy of formation of CH4. Here I am sorry. 4H. You consider this is enthalpy of reaction of CH4 minus summation of delta zero formation of C plus 4 into delta H0 formation of hydrogen. Okay? What is that value? 218 minus respectively CH4, therefore minus 75 minus CH4 717 plus hydrogen 4 into 218. This value is minus 1664. What is this? This is the enthalpy of this reaction. What is the reaction? In this reaction, CH4 is formed. What happened here? A carbon and 4 hydrogen. 4 hydrogen. Look at here. 1 hydrogen here and 1 hydrogen here. In this case, in this formation, 4 bonds are formed. Am I correct? That's only the reaction. In this reaction, nothing happened. A gaseous carbon atom around which 4 hydrogen, they just joined. What is that? For that reaction, this much heat is released. Therefore, this is the heat released by formation of 4 CH bonds. Therefore, heat released by 1 CH bond is minus 1664 by 4. That is minus 416. Now the question, what is the bond enthalpy? Bond enthalpy should be answered as a positive value, exothermic, because this is the value represent for heat released when 1 CH bond is formed. Therefore, bond enthalpy is equal to delta H0 bond enthalpy is equal to 416. 416. Am I correct? Yes. Please understand again. You have given enthalpy formation of this. From this you calculate enthalpy of reaction. When you closely watch the reaction, it is nothing but 4 hydrogen are joined to a central carbon. That is only the reaction. Because of that reaction, this much heat released. Therefore, heat released for 1 CH bond formation is this. Bond enthalpy should be always enthalpy. That's the definition. Okay. Now we can go to another question. Yes. another question. Let us see next question. Students, calculate, this is a question, calculate delta H0 formation of CH4 and average bond energy of CH bond. The data given, look at the data. CH4 gives CH3 plus H, delta H value kilojoule per bond values 435. CH3, that is CH2 plus H, 444. CH2, that is CH plus H, 444. CH gives C plus H, 339. Now C graphite to C gas, 717. H2 to 2H dissociation, 436. Okay, this much good. What is the enthalpy of formation of CH4 and CH4 bond energy? CH4 bond energy, this is a bond energies of each bond breakage. Therefore, CH4 bond energy, let us do that question first. Bond energy of CH4, average bond energy of CH bond is average of these three, that is 435 plus 444 plus 444 plus 339 all divided by 4. Okay, all divided by 4, you will get that answer. 415.5, 415.5 almost. Okay, kilojoule per mole. Now let us go to delta H0 formation. Delta H0 formation. When you write delta H0 formation, they are asking you what is delta H0 formation from bond energy. Delta H0 formation means C graphite plus 2H2 gives CH4. Later, in the earlier problem, we have done a delta H0 formation, that is C gas plus 4H plus CH4. This delta H0 formation and this delta H0 formation are different. This is delta H0 formation. This is delta H0 reaction. It's a really reaction. Understand, these are both different because this is standard state. Because these are elements. Really, enthalpy of formation, when we discuss enthalpy of formation, we have said that standard enthalpy of formation of a substance is nothing but it is formed from its elements. They are pure state. They are standard state. Here, CH4 is not formed from its standard state. Therefore, this is not standard enthalpy of formation. This is a really standard enthalpy of formation. Please understand that difference. Okay. Now, we can consider this delta H0 formation as a delta H0 reaction. This delta H0 reaction, if you take it delta H0 reaction, in terms of bond enthalpy, summation of bond enthalpies of reactants minus summation of bond enthalpies of products. Okay. Reactant, what is the bond enthalpy? Because it is a graphite, should be converted into gaseous carbon, that is 7.7. Hydrogen, what is the bond enthalpy of H2? This plus 436 into 2, because you have a 2 mole of H2 bonds, 2 mole of HH bond, minus, what is the bond enthalpy of CH4? One option is, you have an average bond enthalpy, that is 1.5 into 5, that is the average bond enthalpy of 1 CH, but in this molecule you have 4 CH, so feed into 4, or otherwise you add this. This is all answers together. Enthalpy of reaction. Therefore, here enthalpy of reaction has been considered as enthalpy of formation. Therefore, enthalpy of reaction or enthalpy of formation can be calculated using bond enthalpy, but very careful. Summation of bond enthalpies of reactant minus summation of bond enthalpies of products. Here you have to take care. Here you have a HH bond. How many HH bond? 2. This value for 1 HH bond. That's why I multiplied here 4. In the CH4 here only 1 mole, but I have put here 4 because within the molecule you have 4 CH bond. Therefore, within 1 mole of CH4 you have 4 mole of CH bond. That's why you multiply with the 4. Now that should be very careful. I just give you one example. One. Suppose you talk about 2C2H6 plus O2 gives CO2 plus H2O 2, 3, 7, 2, 4, 6. Almost I can correct. Okay. Now you have a CH bond enthalpy, you have oxygen bond enthalpy, you have C double bond or bond enthalpy, you have OH bond enthalpy. Suppose when you apply, very careful, C2H6, H, 6 CH bond enthalpies, not 6, 12 CH bond. Why? 1, 2, 3, 4, 5, 6 CC bond. 1, 2, 3, 4, 5, 6. 6 into 2, 12. Plus 7 into OO bond enthalpies minus C double bond O. How many C double bond O? 2. 2 into 4, 8 C double bond O bond enthalpies plus OH. How many OH bond? 2. 2 into 6. 12 into OH bond enthalpies. Very careful about this calculation. If you're missing any points, you will get the wrong answer. Okay, that will help affect you. Therefore, bond enthalpy calculation, when you do the bond enthalpy calculation for enthalpy of reaction or enthalpy of formation, this clarity should be very important. Therefore, I always use it to say this. Here one more bond, that is CC bond plus CC bond also. 1 CC bond. This 1 CC. Therefore, I always use it to say the students, write the structure in the complete formula like this. 2, 4, then just do the calculation. Otherwise, there will be chance of error. Okay? Yes, we can meet in the next class with another topics. Have a nice day. You share the topics. you share and subscribe the channel. Okay.